Hey everyone, welcome back, and today we'll be doing another Leetcode problem number 538, convert binary search tree to a greater tree. So this is a medium one. Given the root of the binary search tree, convert it to a greater tree such that every key of the original binary search tree is changed to original key plus sum of all the greater values present in the binary search tree. So this is a binary search tree, meaning it satisfies these three conditions. The values left to it are less than it and of a certain node, you can say, and to the right of it there are greater values, and that's it. So if we have our binary search tree like this, then 0 is the least value in it, so it will be having the most sum, and we will be calculating the whole tree sum to put it here. And 8 will be having the least sum, you can say, because there is no value greater to it. So if you start from our root, what we can do is just uh, go to the right and go to the right till we hit, you can say, because why we go to the right, because on the right we are going to have the larger values, so we can obviously put at this for the sum of its right values, then adding them to 4. Okay, so if we add these four nodes, then it will be making 26, and 26 added with 4 will make 30. Now we will go to the right to the 6, and we see that 6 does have its own right, so we will go till 7, and 7 does have its own right, we will go till 8. Now while we starting from 8, now why not 0, because from 8 we can just save all the you can say the sum in a variable in which will we be using to put it on the uh, left, you can say, to the 0, because 0 is having all the sum of all the tree, you can say sum of every node of the tree, so node value. So 8 will be having no right, so 0, no right meaning 0, so if there is a 0 we will be adding it to 8. And now it will be tracing back, you can say it will be like a recursive call, it will go to the 7, it will be returning 8 at that point, and 8 will add up to it and say 7 plus 8 will be 15, and now 15 will go back to its parent, and which is 6, and it will make 21. Okay, so now it is more like a reverse in order traversal, because we go to the left, then root, then the left. So now we will add the root, and then we will go to the left, and 26, because 5 added in 21 will be 26, and now this whole subtree is done. We'll be tracking back to 4, and now we will go to the 4's left. Now 4's left does have its own right and again right, so we'll be calculating this first before adding it to 1, because the root will be coming in between after the right and before the left. So here the sum is 36, and now we have calculated the whole sum, and we'll be adding it to 0. So what we'll be doing is just making a current variable for sum, so current sum will be equal to 0. Then again you can make a function dfs, which will be taking a tree node and returning the output, which will be, I think, current sum. No, yes it is, because yes, this will change the root, you can say, this will change the values. So the root will be the same, so not root. If there is not a root, meaning then we will be having a 0. So if there is a root, then we know that we have to take its value, so temp. But before that we want to call root dot right, at root dot right, because we want to go to the right. So when we reach to the right, and again this recursive call will make, then we reach 8. So if we 8, then we will be just capturing, you can say, just saving that value. So root dot val will be like temp is saved in temp. Now we want to add, so root dot val will be added by our current sum. So current sum, whatever it is now 0, so we'll be adding it in here. And now after we have our current sum added in root value, so we know that we are going to add the whole sum in the next node we are going to face, which will be the parent node. So current sum is going to be temp. Okay, So after this, what we can do is go back to the right, so root dot left, and after going back, we can just pass it the root, then we can just return root. Not like this, just root. Okay, let's see if this works or not. Uh, Current sum. Yes, this is going to be non-local because we have already made it outside the function. So current sum, non-local. Okay, so this will work now. Yes, this works, and let's submit it. That's it.